Hello students, I am Neeta Upadhyay and I am going to teach you Gravitation Part 3. Students, we have already discussed about universal law of gravitation, which is also called as Newton's law of gravitation. So we are going to solve some numericals related to it so that you can easily understand how to apply it. Now your first question is, what is the force between two spheres weighing 20 kg each and placed 50 centimeter apart? That means there are two spheres and both are having 20 kg. So here M1 is equal to M2, both are 20 kg. Okay. Distance between them is, that is R is 50 centimeter. So R is equal to 50 centimeter, but we have to change it into, just see the unit, kilogram. This is all in SI unit. We have to change this into SI unit, that is meter. And 1 meter is equal to 100 centimeter. So you will get the answer as 0.5 meter. And G value is constant, 6.67 into 10 to the power minus 11 Newton meter square kilogram per kilogram square. Now students, you can write this like this also, 6.7 also you can write. No need of writing 6.67. You can round up and you can write down 6.7 also for making your calculation easy. Here I have used 6.67. You can write 6.7 also. How you will get 6.7? Because this 7 is greater than 5. So it can be added here plus 1. So it is 6.7 into 10 to the power minus 11. So you can use 6.7 also. In many books you will see that it is written at 6.7 into 10 to the power minus 11. That is no problem. It is the same thing, only they have rounded up. Okay. So now you will put the formula. That is force is equal to G M1 M2 upon R square. So G value we know that and mass is 20. So 20 into 20, both are 20 upon 0.5 into 0.5. Answer is this, 1.06 into 10 to the power minus 7 Newton. Now students, you will, when you see such questions, you become very much puzzled that, oh my god, how to calculate? No, but it is very simple. Only steps. Stepwise you solve the problem. Very simple calculation it is. Only little bit accuracy is needed and stepwise you solve. Don't try to solve together. Okay. Like first of all, can you see here that 0. Here it is written 0.5 and here also 0.5 is there. So we can't divide the decimals, no. We have to change the decimals into, we have to change this decimal. We have to remove this decimal. How you will remove this decimal? It is one place here you need, that is into 10 and here into 10. But what you will do, that means it is into 100. So we will multiply the numerator and the denominator with 100. And when you divide this 0.5 into 0.5 into 100, when you multiply this 0.5 into into 100, and in the numerator also you have to put into 100. Okay, you can't change like this directly, you can't multiply here. You have to make do on the both numerator and denominator. So here it will become 5 into 5. So first step is to remove the decimal. So this will become 5 into 5 and here it will, you will get that, here you will get into 10 2, 10 raised to 2. Okay, now you have 10 raised to 2 in the numerator. Now this much is solved. Now you can easily cancel. It will be 1 here you will cut 4, you will get, here also you cut 4, that means 16. Now you multiply 6.67 into 16. Okay, 6.67 multiplied by 16. 4 into 4, 16. Okay, you shift the numbers together. Okay, you take the numbers together and this 10 raised to minus 11 separate. Okay, so here I am taking 10 raised to minus 11. We have taken this separate and we have taken the number separate. Now you multiply the numbers. 6.67 into 16. You will get the answer as 106.7. Okay, you will get 106.7 into, here when you do, you know how to do, the base are same, 10 and 10. So what you will do, minus 11 plus 2. You know the rules, no? So minus 11 plus 2, you will get 10 raised to minus 9. So you will get the answer as 10 raised to minus 9. Okay, this you will get actual calculation. Now students, when you will get this calculations, you will think now answer is written like this, the decimals are shifted and here it is written 10 raised to minus 7. Students, this is the actual calculation, but this is according to the scientific notation. We have to follow the scientific notation because in the numbers are here very large, 106.7. These scientific notations are used in calculations to make it easy for us to write. Okay, for very big numbers and for very large numbers you can make it too small, and very small numbers you can make it to a comfortable number, convenient way. It is a convenient way of calculation. Okay, that we can say, understand about scientific notation. So we have to change it into a scientific notation. How can we change? We will shift this. That means here this decimal we will shift to one place, 1, and then here how many place? It is becoming 2 place. 2 place we have shift. So you will get as 1.067 after shifting. Now you have shifted 2 places. So here also we will add here 10 raised to 2 places means 10 raised to 2. So my 10 raised to minus 7, it will become 10 raised to 2 it will become, and you will multiply with this 10 raised to 7 multiply by 10 raised, sorry beta, this is like this, 10 raised to minus 9 multiply by 10 raised to 2. So what you will get? 10 raised to minus 7 Newton. So I hope that you will understand this way you have to calculate. Why we have done this? You have to understand step by step what I have done first. What it should be, first you will remove the decimal places here. Okay, so first step, removing the decimal place. To remove the decimal place, we have to multiply the numerator and denominator accordingly. We have to shift two places here. This 1 into 10 into 10, that means 10 raised to 2, that is 100. So we will multiply the numerator and the denominator with, we will multiply the numerator and denominator with 100. When you do this, this decimal sign goes and you will get 5 into 5, and here you will get, here in the numerator 10 raised to 2, you will get as 10 raised to 2. Now you can cut 1 into 5 ones are 5 ones are 4 4 16, you will get, here you will get 16, and then here you will multiply 6.67 into 16. You will get the answer as 106.7, and here 10 raised to minus 11 you will multiply with 10 raised to minus 9. Sorry, 10 raised to minus 11 you will multiply with 10 raised to 2. Okay, not 9, okay, by mistake. So after that you will get, when you will solve this, you will get 10 raised to minus 9. Okay, I am just revising again, students. After minus 11 plus 2, you will get 10 raised to minus 9. So final answer you will get 106.7 into 10 raised to minus 9. You can calculate while seeing the video. Okay, you can easily, you can understand by actually yourself, you can calculate. And finally you will get this. So to convert it into scientific notation, we are shifting to two places. And so here also into 2 it will come. 10 raised to minus 9 into 10 raised to 2, that means you will get 10 raised to minus 7. So this is the, we have representing into scientific notation. So in this way, students, you can understand the calculations of the numericals. In this way you will do stepwise numericals, and it will make it easy for you, and you will understand more properly, and stepwise you do the calculation. I recommend you that. Okay, and once you will do know, it will be easy for you. Don't be in a hurry to solve, because calculations are easy, but you in overconfidence you can get the wrong answers. So it's better that you always be careful while solving. Have patience. In this way you are going to solve the other sums also. Okay, we will solve the other sums also. Like this one. A sphere of mass 40 kg is attracted by a second sphere of mass 15 kg. So here again same figure we will imagine, or you can draw a figure also at the side. Okay, so one is 40 kg, another is 15 kg. So we will mention M1 as 40 kg and M2 as 15 kg, and distance is 20 centimeter. So we will change it to SI unit, that is 0.20 meter. Now they are saying that with a force of 0.1 milligram weight. So here force is 0.1 milligram weight. So we have to change it to Newton, that is 0.1 into 10 raised to minus 6. This is the method of changing. Okay, kilogram weight. Okay, milligram it is there, we have to change it to kilogram. Okay, so you will get as 0.1 into 10 to the power minus 6. Okay, why we are milligram, we are changing to kilogram, SI unit, no? So you will get, and you will multiply this with 9.8 also. Okay, we have to change it to this form. Force we have to change in the form of, okay, it is a milligram weight, so we will change it to kilogram weight. and you have to mention the 9.8, the value of force acting on the objects. So you will get you will multiply 10 raised to minus 6 into 9.8. So using the formula F is G into m1 m2 upon r square, you will get here 0.1 force F value is given. We have to calculate the gravitational constant. That means force we know 0.1 milligram weight. Now students, again understand why I have written 0.1 into 10 raised to minus 7. We have to change it to kilogram. Newton. What is the Newton unit? Okay. We have to, this is milligram, we have to change it to kilogram. And weight is 9.8. We will multiply this into 9.8. So finally the force is 0.1 into 10 raised to minus 6 into 9.8. So 0.1 into 10 raised to minus 6 into 9.8 into what is the this distance, r square, 0.20 the whole square, and 40 into 15. Same way we'll do the calculations and you will get this answer. Okay, so this is the way of calculating. So this is how you will calculate the value of gravitational constant G when force is given, mass is given, and the distance between the two objects is given. This is the way. Then you will use this formula, which is the same way. This is the same formula but only shifted. Okay, G is come here. It is shifted. Transpose. You know that you have done transpose in maths. How to transpose. Okay. So this is the way of solving. Let's move on to the next sum. The mass of the earth is 6 into 10 to the power 24 kilogram. Here mass of the earth is given, moon is given, and the distance between earth and moon is given, 3.84 in 10 to the power 5 5 kilometer. Calculate the 8 kilometer it is. Okay, it is not clear students. Calculate the force exerted by the earth on the moon. Okay, so here first you will write down what is the mass of the earth, then you will mention mass of the moon, distance between them. So it is 10 raised to 5 only, then we have to change it. Okay, we have to change it to meter. Okay, that's why here it is written 5, here it is kilometer. Just see carefully students. Here it is kilometer and this is 10 raised to 5, and we will change it to meter here. So then you will get the answer as 10 raised to 8. You know that how to change kilometer into meter. 1 kilometer is equal to 1000 meter. So in this way this 10 raised to 5 will become 10 raised to 8. You will multiply it, okay, into 10 raised to 3, that is 5 plus 3, that is 8. Okay, in this way you will get the meter. Then here you will put the formula, you will substitute, and same way students you will know how to solve the exponents and power. Okay, this 8 and 2, what it will become? It will be multiplied. 8 2s are 16. This will become 16. 10 raised to 16 it will become when you square it. And then you have to square this. You have to square. And you have to first solve the numbers together and powers together. And you will get the answer like this. Try to solve this. It is very simple. Stepwise you try to solve. Once you do the practice, it will become easy, and if you have any problem, you can consult me. Okay. Next, this numerical which we are going to do is related. This will show the relation between Newton's third law and gravitation. We know that what is Newton's third law. To every action there is equal and opposite reaction. That means if the two objects will exert equal force on each other, action and reaction, force will be equal, so result should be also equal. That means if one object exert force on another and second object exerts force on other, the the movement should be same. But it is not always same, which as we have discussed in our previous video. Why do objects do not move towards each other? Because of they have very small mass. So in this sum you will understand about this, how the mass is affecting. Okay, why a stone falls towards the earth, why does the earth doesn't move towards the stone? Okay, both are exerting same force, but why the earth is not moving towards the stone, why the stone is moving towards the earth? Okay, so this you will understand through this numericals. Let us see. Calculate the gravitational force of attraction between a stone weighing 1 kg. So here the stone is having mass of 1 kg and the earth is weighing 6 into 10 to the power 24 kg. These all are the values which you, if you will remember, it is very good. But all the mass of this earth, moon is already given in the numericals. What will be the first, what we have to find out? Acceleration produced in the stone. So we have to find out the acceleration produced in the stone. That means the stone will move towards the earth. So how much is the acceleration? Second, acceleration produced in the earth. How earth will move towards what will be the acceleration of the earth when it is moving towards the stone? So this will help you to understand. So first we will find out the acceleration produced in the stone. So radius of the earth is given here. Okay, it is 6.4 into 10 to the power 6 meter. It is mentioned also beta. It is also mentioned in the sums also. Values are always mentioned. If you want to remember, it is very good that you remember the radius of the earth, the mass of the earth. Okay, it is very good. And here 6.67, this is the gravitational constant. This is already given in the sum. So let us start. We have to find out the acceleration produced in the stone. So first we will use the formula, this one, F is equal to G m1 m2 upon r square. G we know that, we'll substitute the values. Here m1 will be the mass of the earth. Here there are two objects. One is the earth and another is a stone. Okay, m1 is the mass of the earth and m2 is the mass of the stone. So now we will multiply it, and here this is the radius of the earth. The stone is on the surface of the earth. Okay, the stone is here. So here it will be, here we are going to see the distance between the stone, and this is what it will represent. The distance between the stone and the earth will represent the radius of, will be represented by the radius of the earth. So you will only write the radius of the earth, and then when you will calculate, you will get 9.8 Newton. Now this is the value of force. Now acceleration produced in the stone, we know the formula of force, F is equal to m into a, mass into acceleration, and you shift, then acceleration is equal to F upon mass. Then you substitute, what is F? 9.8. What is the mass of stone? 1. So here what is the acceleration on the stone? 9.8 meter per second square. This is the acceleration due to gravity. So the stone is falling, is moving, or you can say falling towards the earth, or the stone is moving towards the earth, and the stone is having 9.8 meter per second square. Now similarly we will find out the acceleration produced in the earth. Same way, F, and here mass of the earth will mention, upon 6 into 10 to the power 24, you will get this much. Now here see the compare the acceleration values. This is very small, 6.63 into 10 to the power minus 24 meter per second square. So acceleration is very less than the acceleration of stone. Okay, So the acceleration produced in the earth is extremely small. Therefore, we cannot feel the motion of the earth. And we can see the motion of the stone because the acceleration on the stone is 9.8 meter per second square. The stone is accelerating. So that's why we do not see the motion of the earth, because the acceleration is 1.63 into 10 to the power minus 24 meter per second square. It's very, very small. Now, students, you will remember that I have told you that we cannot see the things moving in our daily life, objects which are kept towards each other, because the mass is less. So you understand the relation now. Okay, the reason is that the acceleration produced in a body, that is, you know that this is the formula, A is equal to F upon m. Or we can say that acceleration is, you can say it is inversely, it is upon. So acceleration is inversely proportional. I have already made you understand that what is inversely proportional. Like F is inversely proportional to the square of distance between the two objects. So if the distance is more, the force is less. If the distance is less, the force is more. Similarly, if the mass is less, the acceleration is more. So here same thing is happening. The mass of the stone is less, so the acceleration is more. Here mass of the earth is more, so the acceleration is less. So due to the large mass of the earth, the same gravitational force produces very small acceleration in the earth. The stone will also exert same force on the earth, and the earth will also exert same force according to Newton's third law. Both the forces acting on each other are equal, but due to the mass, the gravitational produce is very small, or you can say the gravitational force produces very small acceleration in the earth, because the mass of the earth is very large, because acceleration is inversely proportional to the mass. If the mass of the object is less, the acceleration of the object will be more. If the mass of the object is more, the acceleration will be less. And if the difference between them is, sometimes the acceleration is so much that it is negligible. The gravitational force produces very small acceleration in the earth, that is negligible, you can't feel it. It is it is neglected value. Okay, this acceleration in earth is too small to be detected. It is so small that it can't be detected, and hence we do not see the earth moving towards the stone. So this numerical will make you understand how the Newton's third law and gravitation are related to each other, and why does the stone move towards the earth and why does the earth do not move towards the stone, because of the relation that acceleration is inversely proportional to mass. I hope that you understood the numericals and calculations. If you have any doubt, you can concern me. And so, thank you, students. Take care.